I'd say this is definitely a level 4, level 5 problem, so definitely hard. Now, I'm going to show you two ways of doing this. One is by plugging in numbers, and the second will be the proper way. So the first one is you're really trying to hack this problem, and you want to come up with a number for x and y, so it gives you 32 over here in this original expression. So let me make x, let's say 10, and if I make x 10, y must be 4, and here's why. 10 times 4 is 40, 2 times 4 is 8, and 40 minus 8 is 32, so that's why 10 and 4 works out. So now if that's the case, this will be 16 to the 10th, and that will be 4 to the 4th. Now, if you look at the answer choices, this obviously doesn't match up, so what we have to do is simplify this expression a little bit. 16 to the 10th is the same thing as 16 10 times. That's what's happening in 16 to the 10th. 16 is getting multiplied 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, each 16 can be rewritten as 2 4s. So think about that for a second. If I have 10 16s here and each 16 gives me 2 4s, how many 4s will I have over here? 20. Because if there's 10 16s, each 16 gives me 2 4s. So 2 here, 2 here, 2 here, and 2 everywhere. So that'll be 24s. And then now in the denominator, I still have 4 to the 4th. So what I just figured out was how I can rewrite 16 to the 10th. 16 to the 10th can be rewritten as 4 to the 20th. And the denominator, I still have 4 to the 4th. See, now it's getting a little bit simpler because if I have the same base, I can subtract my exponent. So this will become 4 to the 16th. And just a quick lesson here also, 4 to the 20th is actually 24s. So that's what you have in the numerator. And the denominator, you have 4 4s. So this 4 cancels that. So essentially these 4 4s have canceled out 4 4s over here. So how many 4s do you think you'll be left with? 16 4s. So that's one way of thinking about it. And the second is if you have the same base, you subtract. Now we're left with 4 to the 16th. And again, if you look at the answer choices, 4 to the 16th doesn't match up with any of them. But we can apply the same exact concept as we did over here to simplify this further. 4 to the 16th is, I'm not going to write all of these out this time. 4 to the 16th is 16 4s, and each 4 gives me 2 2s. So if there's 16 4s over here, and each 4 gives me 2 2s, you'll have double the 2s, so that'll be 2 to the 32. And that's what my final answer is, 2 to 32. Which is answer choice C. So that's one way of looking at this problem. And one other thing that I want to point out over here, see that 4 right there? Think about how you can rewrite that 4. A 4 can be rewritten as 2 squared. And then that 16 is still there. Now, if you are raising an exponent to another one, you just multiply these two. So 16 times 2 is just 32. So that's 2 to the 32. So that's actually simpler, but I just wanted to expand it all out to show you exactly what's happening. Now, let me show you the proper way of doing this, and I think it's important to understand the proper way of doing this. It's faster, it's a little bit simpler, but at first it could be a little bit complicated. So let's erase all of this stuff, and let's get to the proper way. So let me rewrite the problem as saying 16 to the x and 4 to the y. Now, one thing to keep in mind is the only piece of information this problem gives me is that 4x minus 2y equals 32. And then asking me what this equals. So this definitely has to be something important, right? Because that's really the only information I have. So I gotta figure out how to rewrite this. Now, one of the things that the SAT loves testing on is if you know how to rewrite bases. So if I have 16 to the x, 16 is the same exact thing as 4 squared. So if I were to rewrite that 16, I can do 4 squared to the x. But now if I'm raising an exponent to another one, that's just multiplying. So this is actually just 4 to the 2x. And I can simplify this further. See that 4? It can be rewritten as 2 squared. So now that 4, I rewrote that as 2 squared. But remember that 2x is still there. So that becomes, I'm going to multiply these out again. So 2 times 2x is just 4x. So finally over here I have 2 to the 4x. So what I've just done so far is rewritten 16 to the x, and I can rewrite 16 to the x as 2 to the 4x. So let's rewrite that over here, 2 to the 4x. Now we're going to do the same exact thing with the denominator, 4 to the y. 4 to the y, we know that 4 can be rewritten as 2 squared, and you still have that y sticking around over there. And now 2 times y over here is just 2 times 2 to the y. So I have that as 2 raised to the 2y. Now if you have the same base, remember, if you have the same base, you subtract your exponent. So this becomes 2 to the 4x minus 2 to the 4x minus 2y, because I'm just subtracting this and this. Now if it all connects, look at that. It was telling me 4x minus 2y equals 32. So I know that 4x minus 2y is 32, and that's why the answer is 2 to the 32.